Sup y'all, and welcome to The Planet and Humanity, Part 1. In this video, we're going to start looking at environmental geography, focusing on the human impact on water and air, and ask this essential question: what impact has human activity had on the waters and in the atmosphere?
And now for something completely different.
We're going to start by looking at how the continents got their shapes. And it should come no surprise to any of you that it all boils down to geography. The speculation that continents might have drifted was first put forward by Abraham Ortelius back in 1596. He worked under Gerardus Mercator, yes, the same one who made the Mercator projection.
Well, Lottie frickin' da!
Centuries later, in 1912, Alfred Wagner formed his theory of continental drift independently and was more complete than his predecessors. He noted that many fossils of extinct organisms were found on lands that were now far apart. Wagner suggested that when the organisms were alive, the lands were joined and the organisms were living side by side. Today, this is all but proven through plate tectonics, a theory that describes the large-scale motions of the Earth's lithosphere, composed of the crust and the upper mantle. These gargantuan plates ride on top of the molten magma below. Now, the Pacific Ring of Fire is an area where a large number of earthquakes and volcanic eruptions occur in the basin of the Pacific Ocean along the tectonic plates. Along these lines where you see a great deal of earthquake origins and active volcanoes. Along a 25,000-mile horseshoe shape, the Ring of Fire has over 450 volcanoes and is home to over 75% of the world's active and dormant volcanoes.
For everyone else who's here, let's get down to brass tacks.
Aside from natural phenomena, humans are causing unprecedented environmental stress. As the ecumene and total population expands, there continues to be negative impacts on the ecosystem through deforestation, soil salinization due to improper irrigation techniques, overfishing, soil contamination due to the introduction of a plethora of chemicals, desertification intensified through overgrazing, as well as other human-induced impacts. We'll first take a look at water, which is a renewable resource, meaning that given enough time, it will replace itself through natural causes. Other examples are the atmosphere, wood, and solar energy. This, of course, is in contrast to non-renewable resources, which cannot be easily replaced through natural means on a level equal to its consumption. Examples include most fossil fuels, such as coal, oil, and natural gas, as well as metals from the earth. Now, fresh water is distributed worldwide through the hydrologic cycle. We'll start the sequence with the evaporation of water from the surface of the ocean. As the air is lifted, it cools and water vapor condenses to form clouds. Moisture returns to the surface as precipitation, and most water returns to the oceans through runoff from rivers and streams, with some water seeping downward into porous water-holding rocks called aquifers. These provide millions of people with steady and reliable sources of fresh groundwater. In South Florida, we receive a great deal of our fresh water through the Biscayne Aquifer. When rainfall is too low, salt water can seep in due to overuse, and this can cause permanent damage. Even water from nearby Lake Okeechobee is not always enough to offset normal demand, so water restrictions are often enacted. In many areas of the world, people have congregated in places where water supplies are insufficient. For example, Israel is a country with around 6 million people, but they consume 3 times as much water as Jordan, the West Bank, Gaza, and the Palestinians combined, a population of around 7 million. And the proposed Palestine contains key fresh water sources for Israel. So this is a classic allocational boundary dispute.
Aha! Aha!
And you can see why forming Palestine is more complex than it looks on the surface. Now, worldwide, about 70% of all the world's water supply is used in agriculture, and another 20% is used for industries. And one of the great ecological disasters of the 20th century occurred in Kazakhstan and Uzbekistan, whose common boundary runs through the Aral Sea. Streams that fed this large body of water were diverted to irrigate the surrounding desert, mainly for commercial cotton production. Heavy use of chemical pesticide ruined the groundwater below, causing a health crisis that some observers described as an ecological Chernobyl. In the meantime, the Aral Sea began to dry up, and by the mid-1990s, it had lost more than 3/4 of its total surface area. By 2014, it was revealed that the eastern basin of the Aral Sea had completely dried up, and is now called the Aralkum Desert. Another interesting story deals with the Great Pacific Garbage Patch, which is a gyre of marine debris in the central North Pacific Ocean, which extends over an indeterminate area, with estimates ranging very widely, with some suggesting it may be as large as the size of Texas. The patch is characterized by exceptionally high concentrations of plastics, chemical sludge, and other debris that have been trapped by the currents of the North Pacific Gyre. Despite its size and density, the patch is not visible from satellite photography, so you can't see it on Google Earth.
Wrong.
Trust me, I've tried. And there are also smaller, yet significant garbage patches in the North Atlantic and Indian Oceans as well. And to get a picture of how vast the Pacific Ocean truly is, and how complex the gyres are, in 1992, a container filled with thousands of rubber duckies, among other cargo, fell off a ship in the middle of the Pacific, and these toys floated around the world for years. Duckies landed in places like Australia, Indonesia, the US, and across into Europe, even up to 15 years later.
And now for something completely the same. A man with 3 buttocks.
Moving on to the atmosphere, one thing that has been constant about the climate throughout history has been change. The greatest driver of this change has been the sun. During times of few sunspots and solar activity, the Earth has descended into long spans of cooler temperatures, such as the Little Ice Age, lasting from around 1350 to around 1850 CE. That said, as global populations expand and develop, our capacity to affect the environment has swelled to unprecedented levels. While there are some natural releases of chlorofluorocarbons, or CFCs, by the 1980s, by far most of these gases were released through anthropogenic means, meaning man-made. CFCs are compounds that were found in refrigerants, propellants, and aerosol cans. When combined with the ozone layer of O3 in our stratosphere, CFCs combine with the ozone, making heavier particles and fall back down to Earth. A so-called hole in the ozone layer was discovered over the pristine environment over Antarctica, and policies were enacted to almost completely eradicate CFCs from industrial and human use. And so the ozone, for the foreseeable future, is safe. A greater current concern deals with anthropogenic greenhouse gases that can trap more heat within the atmosphere, such as carbon dioxide, methane, and nitrous oxide. And while we release millions of tons of these gases each year, most comes from natural causes, such as the decomposition of vegetation. The greatest greenhouse gas of all is water vapor, counting toward as much as 95% of the warming effect, of which humans have almost no impact. We also release a small fraction of the overall carbon dioxide as compared with natural causes, and the same goes for methane and nitrous oxide. That said, a large majority of the scientific community claim there is not only a correlation between the increased release of anthropogenic greenhouse gases and rising global temperatures, but that humans are the main cause for this change. Even bovine belching and flatulence is said to be a cause for climate change. That's right, cow burps and farts release methane, and with as many as 1.5 billion cows grazing across the planet, their impact is not going away anytime soon. Anthropogenic actions can lead to acid rain, which forms when sulfur dioxide and nitrogen oxides are released through the burning of fossil fuels. However, acid rain is also produced through volcanic eruptions. Pollutants combine with water vapor to form dilute solutions of sulfuric and nitric acid, and then are washed out through precipitation like rain, fog, or snow. Now keep in mind, you're not going to be burned alive by acid rain, but it can be caustic enough to do great damage over time, such as the acidification of lakes, stunting of forests, loss of crops and fish, and even the disintegration of historic statues. Smog can occur where there are excess amounts of ozone in the troposphere, which is the part of the atmosphere between 0 and 16 kilometers up. Now, smog is tied to, not geography.
Yes, well!
It is caused by human releases of fossil fuels through car emissions and industrial activity. Today, the worst instances of smog occurs in cities within many of the newly industrialized countries, such as Thailand or China.
I fart
fart in your general direction. Your mother was a hamster, and your father smelt of elderberries.